So let's take a look at example 3, solving a system by multiplying one equation. So if I take a look at these two equations, I notice that neither of them can I add or subtract to eliminate one variable. I have, let's make this a little smaller, negative 2x plus 15y equals negative 32. And I have 7x, 7x minus 5y equals 17. Well, 2 and 7 don't really have any common factors or anything, but I notice that if I multiply 5 times 3, I will get 15. So I'm going to take this entire equation and I'm going to multiply it by 3. So that I'm going to rewrite the first equation, negative 2x plus 15y equals negative 32. After multiplying, I get 21x minus 15y equals 51. Now I'm going to go ahead, because I have plus 15 minus 15, I'm going to add these two together. Because 15 plus negative 15 is 0. Negative 2x plus 21x is 19x. Negative 32 plus 51 is 19. Since I have no y, I'm just left with 19x equals 19. Put a plus here. We'll divide both sides by 19, and x equals 1. So I know that the first part of my ordered pair will be 1. Now I'm going to take this one and plug it back into one of the equations. Let's pick the purple equation just for fun. So 7 times 1, because x is 1, 7 times 1 minus 5y equals 17. 7 minus 5y equals 17. I'm going to subtract 7 from both sides. So negative 5y equals 10. Divide both sides by negative 5. And y equals negative 2. Remember, a positive divided by a negative is a negative. So the solution is the ordered pair 1, negative 2. So in this example, we multiplied one equation. And here in example 4, we're going to go ahead and multiply both equations. So I have 3x plus 2y equals 1. And I have 4x plus 3y equals negative 2. So let's start with writing the first equation. 3x plus 2y equals 1. Now I notice I have 3x and 4x, 2y and 3y. While 3 and 4 have a common multiple of 12, 2 and 3 have a common multiple of 6, I'm going to go with a common multiple of 6. It's going to get me a little bit smaller numbers. So in order to make both of these, we want to get both of these to be 6y. So I'm going to multiply this entire equation by 3. So that I get 9x plus 6y equals 3. For equation 2, 4x plus 3y equals negative 2. I want 3y to equal 6y, so I'm going to multiply the entire thing by 2. So I get 8x plus 6y equals negative 4. You know what, I'm going to write that in green really fast. just so that I keep my equations the same. Colors. I like to keep things color-coded. 8x plus 6y equals negative 4. Now I need to eliminate one of these. If I add 6y plus 6y, I'm going to get 12y. So instead, I'm going to subtract. 9x minus 8x is x. 6y minus 6y is nothing. 3 minus negative 4 is the same as 3 plus 4, which is 7. So x equals 7. Now I'm going to take this 7 and plug it in to either of my equations. 3 times 7, or 3x, plus 2y equals 1. 21 plus 2y equals 1. Subtract 21 from both sides. 2y equals negative 20. Divide both sides by 2. And y equals negative 10. So my solution is 7, negative 10. So in this example, we had to multiply both equations by a number to get a common variable that we could then eliminate through addition or subtraction. All right, let's take one quick look at example number 5. So finding the number of solutions. So as we saw when we graphed and when we used substitution, sometimes two lines are parallel. If those lines are parallel, there is no solution. Sometimes two lines are exactly the same. And if those two lines are exactly the same, then there are infinitely many solutions. Every point on one line is a point on the other. So how do we know if we have no solution or infinite solutions instead of one solution, as in examples 1 through 4? So let's take a look at these two lovely equations. 2x plus 6y equals 18, and x plus 3y equals 9. 2x plus 6y equals 18. X plus 3y equals 9. Well, neither of these can be eliminated. X minus, or 2x minus x is x, and 6y minus 3y is 3y, so that isn't going to work. So I'm going to need to multiply one or both of these. If I multiply this bottom equation times 2, I come up with 2x plus 6y equals 18. These two equations are now exactly the same. So without doing any more math, I know that they are the same line and have infinitely many solutions. I don't need to do anything else. They're infinite. Just like in substitution, however, if you do the math and you get down to the bottom, you have no variables left. You get 4 equals negative 13. They do not, so therefore there is no solution. Okay, that's it for examples. Please make sure you've watched both videos. If you have questions, I will answer them the next time I see you.